Hi class, welcome to Math is Fun, Demental. Today we're going to introduce proofs. Now this is something totally new, probably never seen before, so this will just be a little lesson to jump into proofs in geometry. So let's get started with some properties of equality. Now these may seem a little familiar to you, which is good. We have the addition property, which states if A equals B, then A plus C equals B plus C. All that means is if I have some sort of statement like if x equals 5, then I can take a number or a variable and add it to both sides of an equation. So I can say that x plus 2 equals 5 plus 2. So I'm just taking something and adding it to both sides of our equation. Subtraction property, same idea, but this time instead of adding, we'll be subtracting. So if x equals 5, then x minus 2 equals 5 minus 2. So just taking that 2 and subtracting it from both sides of the equation. Multiplication property, moving through here, if x equals 5, then 2x equals 2 times 5. Division property, if a equals b and c isn't 0, then a over c equals b over c, or a divided by c equals b divided by c. The reason c can't be 0, we don't want to divide by 0. 0 is never in the denominator. So here, if I have, let's see, 2x equals 5, then I can say that 2x divided by 2 equals 5 divided by 2. So we can use all these properties. If you're hopefully you're seeing it, we can use these properties to solve an algebra problem. Reflexive property, a equals a. This one's a little strange, and we're going to use it a lot later, but for right now, it's going to seem kind of silly. But for example, the measure of angle 1 equals the measure of angle 1, or we can say AB, the segment AB is congruent. Oops, these are measures of equality, properties of equality. Let me just make that an equals. AB equals AB. So we'll use that again later, but for right now, I think it's just kind of going to be on our back burner. All right, symmetric property, if a equals b, then b equals a. So this just says if x equals 5, then 5 equals x. We can switch them as symmetric property. Transitive property is one of my favorites. Transitive property says if a equals b and b equals c, then a equals c. The reason it's one of my favorites is because I like to call it the transitive train. So here we have a little, and I'm going to draw a little train. We have our little train car, and then our equal signs are like our connectors from our train cars. The B and the B get to go in the same car together, and then C is in the car. And so our little transitive train, we can kind of ignore the middle car and connect A to C because it's all in the same train. So that's how we get our transitive property. So here, if x equals y and y equals 2, then I can say that x equals 2. All right, substitution property is really similar to transitive, just a little different sometimes. If a equals b, then b can replace a in any expression. So for example, we could do a simple replacement like we saw in transitive property, but we could also do something like if x plus y equals 90 and x equals 30, then I can take the 30 and replace x with 30. So I can say then 30 plus y equals 90, and then use that to solve for y. All right, so a very, very common confusion is the difference between transitive and transitive and substitution. So I just want to kind of talk about it a little tiny bit. Transitive property is a type of substitution. So I'm going to draw a little diagram here. So if substitution is this large area, transitive property is a subset of substitution. Transitive. So it's a type of substitution, which means if transitive property applies in your proof, then technically substitution will always work wherever transitive works, but it doesn't always go the other direction. In the example that we put in our table for substitution, transitive property would not have worked for that. So be a little bit careful. I like to use transitive if it's really all equals or all congruent signs connecting all the pieces. Transitive is fun. But if it's not all equals, for example, in that substitution property example where I had x plus y and then x equals 30 and I'm substituting that in, transitive would not apply. So be really careful about the two of those. All right, some properties of congruence. So we had properties of equality, now we have properties of congruence. Reflexive property of congruence, again, is going to be something like segment AB is congruent to segment AB. Reflexive property, think of it like a reflection in a mirror. You're looking straight at yourself, so both sides of those congruent signs or equal signs are going to be the same. All right, symmetric property of congruence. These properties are going to be the same as the properties of equality, except we have congruent signs now. So if x is congruent to, well, let's make these geometrically. Okay, let's say AB is congruent to BC, then I can switch those two things around. I can just say that BC is congruent to AB. So that's what our symmetric property does for us. Transitive property, again, we've got our transitive train. So if A is congruent to B and B is congruent to C, then A is congruent to C. So if, let's just use this example we're going with here, AB is congruent to BC and BC is congruent to CD, then we can say that AB is congruent to CD. So there's our transitive train, or transitive property. All right, and substitution property. So I could say, let's see, if AB is congruent to BC. This one's a little tricky because with congruence, this is going to be very, very similar to transitive. In the last example, we had an equal sign so we could make an equation, but with congruence, it doesn't work quite as well to make the two examples different. So, you know what? I'm just going to say that that works for that one too. Same example for substitution property of congruence. Again, it's a little tricky sometimes when we can use that, but remember, if it worked for transitive, it can work with substitution. The difference between the two, if we go back, this example, substitution property of equality, definitely does not work for transitive, so it's a little bit of a better example. But I can't use plus signs or minus signs or equal signs when I'm talking about a property of congruence, so it's just a little different there. All right, so a proof. So now we get into it. We've got a little bit of our properties to back us up here and to play with. A proof is going to be a series of statements and justifications. We start with the given information, whatever we're given. We have to end with what we need to solve or what we want to prove is true, and we have to justify every step. So this is the difference between just a simple algebra problem solving for x and a proof when you're solving for x or proving something. So let's look at an example. And proofs are going to take some practice, but you'll get them. All right, if the measure of angle 1 is 5x plus 7 degrees, the measure of angle 2 is 3x plus 11 degrees, and we're given that the measure of angle 1 equals the measure of angle 2, then what is the value of x? So it seems like a simple little algebra problem for us, but I want to talk about what a proof is. So we're going to justify every single step just to kind of get into what a proof really is. So first thing we're going to do is start with the given information. So here I'm going to have the measure of angle 1 equals 5x plus 7 degrees, and the measure of angle 2 equals 3x plus 11 degrees. So we'll call this step 1. And we're just going to write the word given because it was given to us in our information for the problem. Now, we're given another piece of information. We're given that the measure of angle 1 equals the measure of angle 2. So I'm going to put that next, and I'm going to put given again. It's a different statement. We can combine. We could have put all three of those in our line 1, but we can also separate them. Proofs give you a little wiggle room to make it your own. All right, now the third step, here's where we want to start doing things to solve for that x. So if I know that the measure of angle 1 is 5x plus 7 and the measure of angle 2 is 3x plus 11, I can take 5x plus 7 and replace measure of angle 1 with that amount. So 5x plus 7 equals, and then I can do the same for measure of angle 2. Instead of the measure of angle 2, I can replace it with 3x plus 11. Now here, we could actually either use, because it's all equalities, we could use transitive property of equality, or we could use substitution property of equality. I'm going to use substitution in this case because I kind of did two different steps in one. I substituted 5x plus 7 in for measure of angle 1, and I substituted 3x plus 11 in for measure of angle 2. So with a couple steps at the same time, I think substitution is a little safer, but again, transitive property would also work here. Substitution property of equality. So we want to write property of equality, and we can symbolize that a little. All right, now let's solve this like an algebra problem, but we need to use our properties to justify our work. So here, I want to subtract 3x, and we can do the work, but we don't want to count it as a step. So you can do this, and we want to do one step at a time. So my next line of my proof would be 2x plus 7 equals 11. So it's not the actual negative 3x on both sides or subtracting 3x on both sides. That's my line in my proof. But we can show that for our own sake if we want. So here we want to think, okay, how did I get from 3 to 4? Well, I subtracted 3x from both sides. Subtracting something on both sides is our subtraction property of equality. So that's how I would justify that step. All right, next step, we're going to do kind of the same thing. I'm going to subtract 7 on both sides, so I end up with 2x equals 4. So on step 5, again, I'm going to get subtraction property of equality. And my last step, if I take and divide both sides by 2, I get that x equals 2. And again, I divided something from both sides, so that's going to be my division property of equality. And that's the end of our proof. Now, if you want to be really fancy, to symbolize that it's the end of a proof, you can put a little box and color it in like that. There's a couple other ways you could do that, but it's just a nice little symbol that states, okay, I'm done with my proof now. So that's a little bit of an introduction for you into proofs. And that concludes our lesson for today. So thanks for watching, and remember, math is fundamental.